Well, good evening and welcome to Space Oddities. Do we see anything? Are we actually live?
We are not, I'm afraid.
No, can't see nothing.
I'm on a page with all my subscriptions on, and it says in the middle, your subscriptions aren't live streaming at the moment. Come back later.
Right.
Oh, hang on. I can see one. I can see it.
Yeah, I can see.
Whereabouts?
Oh, yes, there we go.
It's just
Yes,
popped
we
up,
are.
but
It's
we're
just
not,
popped up.
we're not actually live, are we?
Well, it says live. I
Yeah.
can see it on the internet. Oh, Stuart, live. There you go.
Yes.
Hello, Stuart.
Does the screen that you're seeing match the screen that's on your laptop?
Yes.
Yep.
Yep.
Where are you looking again?
Right, so we're not in the studio.
Oh,
Because
Well, I
all
can't
I'm
see
seeing
anything,
is a
so-
picture.
Well, Stuart's managing to do some texting.
Right,
But
can somebody
nobody else.
reply to me? What can you see?
Ah, Ian's got a aha. So,
You see audience responding.
But we right, what can you actually see on YouTube, guys?
I can see us. I can see us.
I can just see
Yeah.
old videos.
I can
Right,
see us.
Right, are we live or not?
All of our audience says we're live and they can see us.
Yep.
Right.
Yep. We've
All
got
right. All right.
we've got 7 people up on there now.
Right, okay. All right. 1 second. Right, apologies, viewers. We've had a few technical difficulties this evening, but can you confirm in the chat that you can
Yep.
Yeah. or see us? Yes.
So that's strange.
And can you hear us okay? Can you hear my dulcet tones?
All of our audience.
Yeah, well, I'm just going to get rid of this.
Yep.
Got it now.
Right. Okay, great. Okay, fantastic. So sorry about that. We've had a few technical difficulties with the software, but I'm glad that we're live now. Thank you so much for joining us this evening. We have somebody got something.
Yeah, I've just turned it off. Sorry, Andy.
Okay. So thank you for joining us this evening. If you're new here, if you're first time to Space Oddities, we don't normally have these problems, but as you will appreciate, we're dealing with software and hardware, and anything can happen really. So I'm glad we're live. I'm glad you can see us. Welcome. This evening we've got some familiar faces and perhaps not so familiar faces. So let's go round. Aaron, how are you? Right. Okay. Moving on. John.
Yep. Living the Vida Loca.
Man, a few words.
Living the Vida Loca. That's what I like to hear. Lou, how are you?
Oh, life is grand. Life is grand.
Yeah. Looking forward to your talk on Friday.
Oh my gosh, I am too. I wonder what I'm going to talk about.
Titan and life and exoplanets and stuff, I believe.
That sounds about right.
But that'll be the early hours of the morning here, but I'm still going to get up for it. So,
Wow. You're a real astronomer, Andy.
Oh,
Well, there you are.
sorry, have I missed something here?
I've always said that.
Yeah, Lou is giving a talk for the Astronomical League on
Oh,
Friday.
okay.
Yeah.
What's that on YouTube? Is it?
No.
That's a good question. I don't know.
No, there was a link. I don't think it was a YouTube link, but anyway, there is a link. If you look in on the Facebook page, Des, you'll see Lou's posted about it. So we got Michael as always. How are you, Michael?
Okay, thank you. Still
Good.
getting over my cold
Oh dear.
and COVID.
Oh God, yeah. Sorry, I meant to ask you. You're obviously feeling better.
Oh, a lot better now. It's the main thing about COVID was my sore throat. It was really sore throat.
Oh dear.
So, yeah.
You want a fisherman's friend in your mouth.
No.
Michael, I hear that low Earth orbit is a real
Thanks, Lou.
So, Roger, how are you?
I'm fine, thank you.
Good. And I'm
Been
fine.
busy through the night, sorting out meteors and Milky Way shots and
Yeah,
There. You'll find out more about it on my presentation.
yeah.
No.
I'm sure. I'm
Ooh.
sure. But I love that photo of the windmill and the Milky Way. That was lovely. Lovely photo.
Yeah.
Oh yeah.
That came out really well. So
Yeah.
It did.
well done. So what have we got for you on tonight's show? On tonight's show, we're going to be tackling the ancient question of, is there life on Mars? Now, there have been a few recent discoveries on Mars, in particular in relation to one rock, and Lou's going to be talking us through all of that. I found that quite exciting because I think it's one of the best promises for possible ancient life on Mars that we've come across yet. So anyway, I'll let Lou talk about that. Other than that, we've got the usual stuff for you. We've got the news, we've got Daz's Solar Watch, and anything else that comes up, basically. So a few of you have been putting questions in the chat on the Facebook page, things you would like us to answer on the show. And we're going to be answering, we're going to be discussing your questions and hopefully answering them. Don't forget, if you would like us to answer any of your questions here on Tuesday, on the Facebook group, the Space Oddities Live Facebook group, do go there and go to the chat called Your Questions, please, and put your questions there, and we'll answer them for you on Tuesdays if we possibly can. But we've had a few good questions this week, so we'll come to those a bit later as well. So, in time-honoured tradition, I think we need to go over to Roger to find out what's going on in the night sky and to have a look at the viewer gallery. Have we got many in the gallery this week, Roger?
Oh, we've got another massive gallery selection. People are flooding them in now after last week, so we'll carry on with the trend. Right, okay.
Right, then, off you go.
Right, so we're coming up towards the end of August already. So we're 2/3 of the way through 2024. So we've just about had a full moon, and we'll discuss that later. And in a week's time, we'll be on to the last quarter of the moon. So things will be dimming down a bit. Now, here's a comparison of what we had during last night with the blue supermoon, which was rather hyped a bit. It's only 6.5% bigger than a normal full moon, but there we go. Anything bigger than a normal moon is a supermoon, but the picture on the left was taken a few nights ago, and as it was rising, it was a bit difficult to see, and it was quite dim. And as it rose higher, you got this wonderful orangey red glow from the moon, and that's in partly to be blamed from the smoke fires from America coming across on the Gulf Stream to bring all those particles across and darkening and colouring the moon. So it was almost like a blood red eclipse, really. It was quite an awesome sight. If you
Our pleasure,
knew
Roger.
what you were. Yeah.
Anytime.
Yeah, we'll be
Okay.
sending you a bill for the cleanup, Lou.
Yeah, so there's been quite a lot of debris from the ash of the smoke particles and stuff over here. So that didn't go down too well. But there we go. And this is today's view of the sun because I can.
Wow.
And just showing you what there is still available. A lot of it's turned away now, but we have still got quite a few spots and groups coming around. There is a little bit more coming around from behind, but not as much as we have had in the last week or so. But activity is still good. We've still got lots of prominences, as you can see from the image on the right, where you've got loops and all sorts of things going on. So still good activity on the surface. So good. Right, so we've still got the summer triangle dominating the southern area and over the zenith, and we've also got Saturn up quite nicely now. And as the moon gradually fades away, we'll be able to see more of the Milky Way back in the skies again. But we'll be discussing the conjunction of the Moon and Saturn, which will be happening tomorrow morning. But the previous maps were at midnight, but 3 hours later we've got Uranus, Jupiter and Mars up in the night sky, still going through Taurus. So that's been quite interesting, and I've got some pictures of the conjunction between Jupiter and Mars from last week. So it's all going on. As you can see, we've got Orion coming up and Gemini coming up through as well. So winter is coming. So yeah, but still close to the sun. We've got Mercury, which is getting too close for any safe viewing, and Venus, which is still a little bit away from the sun, but that should be visible briefly before after sunset. So keep an eye out for that if you've got a low western horizon. And as you can see on this screen here, we've also got Schunnensen Atlas, but obviously with it being that close to the sun, we've got no chance of visibility for any proper observations of that, but that can be sorted out later on in the year. Okay, so we've still got Comet Obers, although that is now becoming a much fainter comet now. It's still in Coma Berenices, and the values of the magnitudes are going drastically south now, from 8.6 down to 10.2 by the middle of September. So not really becoming too interesting, but Schunnensen's still in sextants, although it is still very close to where the sun is, so it's not really visible. But look at the brightness values going from 7.7 down to an estimated 5. So we're still hoping on that, although some people seem to be thinking that there is a possibility that it might be starting to break up already, but there's no definite conclusion on that at the moment. So we'll just have to hang on and see how the ride goes as it comes in. Right, so we've got an interesting occultation of Saturn by the Moon, but this will be tomorrow morning, starting at roughly 4:30 in the morning, and it will be revealed again as it passes the other side, roughly an hour later. So it'll be a reasonable height, although it will be a bit lower by the time it's come down, and it will be about 24 degrees above the horizon at the start, and about 20 degrees down by the reveal of the planet Saturn, although it will be starting to get brighter in the sky by that time. So it will still be visible, but it will become a bit more of a challenge. This is just giving you an idea of where the moons are in relationship to the before and after of the occultation, and it gives you a rough idea of when they appear before and after the planet has reappeared as well. So they will become visible, although it will be a bit more difficult once it's reappeared, with the daylight coming a bit more stronger to make that more of a challenge.
Now that's only going to occult in the UK. We won't see it here in the States. Is that?
No, I mean if you go up into Scotland, it might just appear just above the surface. So the best opportunities for seeing this over in the UK is down where I am, down on the south coast, because that will the moon will obstruct it for a little bit longer. So the times that I've given you are roughly for central UK. So, but it should be an opportunity, but we're dependent on the weather again, unfortunately. So here we go for the another big gallery, and this was the conjunction on the 15th that I managed to take from my garden. The picture on the left was just done with a telephoto lens, just to give you a visual, an idea of how close the two planets were in the sky in Taurus, and the excuse me, the picture on the right was the field of view from the camera chip that I had, which is a square sensor, and I managed to get the Jupiter with 3 of the moons in and Mars in the corner, so that worked out quite well. And although this is only about a 1200 millimeter focal length with the 2.5 converter in it, you can see the moons quite well and some of the belts on Jupiter. And it just shows you how small Mars is at the moment to the size of Jupiter. It's only about 6.5 arc seconds in diameter at the moment, so it's still quite small. But some people have managed to get some details with a 14-inch telescope or more of some of the surface details, of course, like you do. And here's the picture that I did a week ago of the Milky Way over a windmill. This was part of the Camera Club group. We were getting astrophotography into our ways of thinking. So first trip was Avebury, and then we decided to come to this one as well. So
Lovely.
turned out quite well.
Yeah, lovely.
And the background was lit by the low setting moon, which gives you the bright effect down on the ground there. So it was quite. Yeah, there was about half a dozen of us there, and it was we were the only ones there. And it was lit up to about 11 o'clock. Then the lights went off, and then the fun began.
Did you strategically place that tree in the corner so to block out more on the moon?
No, it was just the location of how it was. I mean, there was a little bit of wind, and the sails were at a 45-degree angle, but the wind just blew it round almost to a profile. So
excellent.
Yeah, it's almost in line with the Milky Way.
Yeah, that was commented on.
Is that a satellite to the left of that sail?
There are a couple there, yes.
Yeah.
We did see a few Perseids, but nothing that became visible during this picture. Okay, so we've gone on to M31, the Andromeda Galaxy by Lou.
Who?
With Lou Mayo.
I've never heard of him.
No, so this was done not with a C star. With his Explore Scientific 127 Apo.
Wow.
Oh, wow.
Wow.
Yes.
Amazing.
Well done, Lou.
Kind of makes you want to cry, doesn't it?
Yeah, certainly does.
What?
That's beautiful.
You've got some nice dark lane material there, Lou.
Yeah.
Very, very nice. And not to be content with sending one image in, he sent another one in of Caldwell 23, which is an edge-on galaxy.
Oh, what's that?
Oh, yes. And we've got the right dark lane material through that one as well, Lou.
That's lovely, yeah.
Did all right there. Very nice.
Yeah, very nice.
Well done. And then Michael.
Oh.
With your Nikon Z7.
Yep.
Does it come back to you now?
Yeah, that was last week. Yeah, that was last week.
Was it?
It's,
anyway,
it's not bad considering the size of the moon in the field of view.
Yeah.
It's still quite small, isn't it, in the full frame?
Well,
there's
some
detail there.
You've still got some good details. I mean, you got the Tycho showing quite well with the rays coming from there as well.
Yeah.
And copper knickers.
Yes, for that as well.
Copper knickers.
Right, now on with Graham. Now he's taken one with his C star of the moon with not much processing on his iPad.
Oh, that's nice.
That's a bit.
Nice.
Yeah, that's nice.
That's got quite a lot of detail there.
Yeah.
Very well.
Yeah.
See all the craters down there. Very nice. Well done. And so he's had a go with the Ring Nebula and used an app called Astro Edit. Not aware of that one, but obviously he's used it. And
Yeah.
you can get to see some of the details there.
The ring is hard to do with the Sea Star because it's so small.
But
It's color.
It's a good attempt. Very good. Recognizable. And then we've got Jerry Delay with his Crescent Nebula, with his usual setup, and got some details there.
Wow.
Very good. You like that? He does very nicely with those.
Nice color.
Okay. And then we've got Lee with the Aurora and Perseid meteor shower from his location with his usual Canon 600 and his Samyang. Here we go. There we go.
Whoa, that's good. That's lovely.
Oh, that's lovely. Look at that.
Yeah.
Got a good collection there, but I think there are a couple of suspicious ones there that might be just satellites, but the majority of them are Perseid meteors.
Yeah. The one towards the middle of the frame to the lower middle.
Yeah.
I think that's a suspicion.
But at least he got more in the frame than most
me.
of us did. Yeah, and me.
And also on the left-hand side, you can see the plough.
Yeah, that's true.
Yes, you can.
Yeah.
Yep. You can see Mizar and Alcor on there.
Oh, right.
Yeah.
That's pretty good with the 14mm there, Lee. Well done.
Yeah, fantastic.
And one from Michael Murphy, which we haven't had for a while. So here we go. So it's the Sun with the Skywatcher ED80 and a telescope service solar wedge.
Oh,
that's nice.
Some nice spots there. Very good. Very nice. Okay. And that will conclude our gallery for this week.
Oh, that's fantastic.
So another good selection of images again. So we, obviously with the night times getting longer, we can get out there and get even more images.
Absolutely. So thank you very much for that, Roger, as always. Thank you, viewers, for sending in your images. As you know, we do love looking at them. If you would like to feature one of your images in our gallery, all you have to do is attach it to an email, mail it to spaceodditieslive@gmail.com, spaceodditieslive@gmail.com. One image per email, please, and if you could put the word gallery somewhere in the subject of the email, that'll make sure that the Space Oddities elves hurry it off to where Roger can find it easily. So there we are, and thank you for that. Just a bit of usual housekeeping, really. Don't forget the Space Oddities merchandise is still available, our wonderful summer 2024 collection. This being that, and this is available in black. The T-shirts are £25, including UK postage and packing. And we've got lovely design there. We've still got the old design available, which is this one. So we've got a choice of two designs. What more do you want? And you can buy these by either scanning the QR code that you see on the screen now. Scan the QR code, or if you look in the chat, there'll be a link that's just popped up in the chat. And we also have the Space Oddities hoodies that are available. The hoodies are £40, including UK postage and packing. And we've also got the lapel design T-shirt, which is the old design. But if you want the design sort of on the lapel instead of in the middle of the T-shirt, there you are. And again, you can scan the code or click the link in the chat. We are trying to expand the range of merchandise for you. But so far, we've run up against, what you would expect as a problem is that anybody who is a manufacturer of this stuff, they always want a minimum order of a few hundred. So we're trying to find ways of getting some more merchandise for you that doesn't involve that. But we will keep you posted on that. So thank you very much. I'd like to apologise again for the technical gremlins at the beginning of the show. There is a bug at the moment in the latest release of our streaming software that they are trying to fix. Until that is fixed, next week will probably be the same. You won't see the stream appear in advance of going live on YouTube, but if you go to the live tab or onto the main page, you should see us there. Apologies for that, but it's beyond our control at the moment. No idea when it's going to be fixed, but it's quite a serious problem, so I expect they'll fix it soon. So apologies for that, especially if you're joining us for the first time. As I said, we don't normally have these problems, but this is technology. So as I said...
And don't forget to hit the notification button. That'll give you a...
Absolutely. And yes, don't forget to like, subscribe, hit the notification icon so that you are notified when we go live. And that's that. Now, I think what we'll do is just before we go to the news, I think we'll just answer a couple of questions that have been put in the chat on the Facebook Live, on the Space Oddities Live Facebook page. And we had a question from Paul about what's the general consensus of life elsewhere in the universe, because he says, quite obviously with all those billions of galaxies and trillions of stars, you would expect there to be some life out there. So I think what we can do, what I'd like to do, break this down into two questions for you, panel. What do you think, first of all, the chance of any sort of life, be it microbial, the lowest forms of life, or otherwise?
Highly probable.
Yeah, very high.
I would say it's
Very high.
so close to 100%, you can't tell the difference.
Good answer, Aaron. Good. And what about within our solar system?
Microbial.
Microbial, yeah.
If we're lucky. Fingers crossed.
Greater than 50%.
In the water.
Right.
I
Do you think there is microbial life on some of the moons, like Enceladus or Europa?
Yes, I think so.
Yeah. Consensus is yes.
Yes.
Consensus is it's a good place to look. As to whether it's there, I think it's too early to tell.
Yeah.
Right.
Yeah.
But there are promising signs of environments where, as far as we understand the requirements for life, it could exist. Yes.
Yeah.
Yes.
We have canisters sitting on Mars waiting to be discovered.
Yeah.
Yeah.
I know.
Yeah,
Well, I offered to go and get them for a very reasonable fee, but nobody was interested.
Pick these up on your way to the store.
Yeah. Yeah. So let's ask the other question. What about what we would term intelligent life? In other words, alien civilizations. What about the likelihood of that? What do we think?
Do you have to define intelligent first?
Yeah, that's what I was going to say.
Yeah. All right. Let's be specific. Spacefaring civilizations.
I think it's a possibility.
Yeah.
Yeah, in the universe, yeah. I mean, it could even be in our Milky Way, our own Milky Way, but the Milky Way is so vast.
Yeah.
That, and this is where the problem lies with finding anything. Is that yes, we all we can do is look in our backyard at the moment, the solar system. Yeah. But once you start going beyond that, the distances are just astronomical. Oh, sorry. But it is. It's just that the distances are so far, and this hinders both radio detection. Our best bet, and this is something we can talk about at a later date, is technosignatures in atmospheres of, or technosignatures, or even just biosignatures in atmospheres. So using the James Webb and things like that. It's a hard question to actually, because we've got to try and wrap our heads around the actual thinking of the distances.
Yeah.
And this is where the problem lies for me. I think there is intelligent life out there, but trying to detect it is hard. I mean, there was one question, I don't know if you're going to answer, Andy, about looking for radio signals. And unfortunately, there's the search for, if there is another civilization out there who invented radios and things like that, it's the same as us. The window is so small. I mean, even we're going quiet now because we're going digital. So you've only got possibly 100, 150 years. And then, of course, then you've got to think about degradation of the signal as it travels through space. And if you want to actually directly send a signal to somebody, it has to be a very, very powerful transmitter.
And of course, there's this whole thing about the fact that we've been broadcasting radio signals since the early years of the 20th century. And people think that, aliens could be picking up our radio transmissions and watching EastEnders on their televisions or whatever. Perish the thought. But that's a bit of a myth, because then by the time they get, not far beyond the sun, they're not coherent signals. Anybody would just pick up more or less a hiss. They wouldn't probably be able to reconstruct those signals. And as you said, you would need an enormous transmitter to send a signal. Okay, so moving on, as part of that question then, let's say we come back in, say, 30 years. What do you think are the chances in 30 years that we will have discovered some sort of life, either in our solar system or beyond? What do you think?
I don't know. We've got JUICE going up in a few years' time, heading off to the icy moons of Jupiter. Whether they're designed to fly through any plumes that might be there depends, again, what the instrumentation's designed to actually pick up. If it's anything more than ions and chemical elements, then it's probably not going to detect microbial life. But if it's the instrumentation is more complex, looking for organic molecules and specific organic molecules, then there's a chance they might find something there.
Yeah, I don't think JUICE is set up to detect life.
Yeah.
I think it is set up to detect the presence of organic molecules, complex molecules that are perhaps important in the development of life on Earth. But it's all indirect. It's all suggestive. It's all consistent with, but also other explanations. I think our best chance in the next 30 years, once again, is to bring those canisters on Mars back and have a good close look at them. I put money that we'll find microbial life.
You think so?
Yeah.
I'll take that bet.
Historic, either current or historic. Yeah.
Yes. I mean, I'd be more inclined to think it will be ancient microbial life rather than current. But, but we don't know. We don't know till we get those samples back. So it's an open question at the moment. So, yeah, absolutely. Aaron, what do you think? 30 years, we're going to find anything?
I'm not as optimistic, I think, as Lou is. But I also feel we owe our listening audience the statement that no matter how much we think life is out there, we haven't found it. And so when you're talking about intelligent life, there's no evidence they have actually been here. And so I think those concepts are important to get out there.
Absolutely.
Yeah.
And Alan says, we've banned transmitting on H alpha, so SETI is searching the wrong wavelengths. Any comments?
Well, with that, SETI have moved more away from radio detection now, and they are focusing more on, because we've got the big telescopes that can actually see the atmospheres and measure the atmospheres of distant exoplanets. They're looking for, as I said earlier, techno-signatures and biological signatures in the atmospheres of these exoplanets. So they have moved away from radio detection. They still do some, and this is a conversation I would like we could have possibly a separate show on, is the history of sort of like SETI and how it all stands, because then we can talk about things like the Rio protocols, and like Lou was hinting at, is sample returns. But back to the original question you asked, Andy, I think in 30 years we'll have, I'm going to hedge my bets here, we'll have a better idea of whether there could be life in the oceans. Because as we said, we haven't actually gone looking for life. But once we start, I mean, we know that comets, meteorites and all that actually carry the organic building blocks. So we know this chemistry going on out in the solar system and in the universe. So for there not to be any sort of life out there, it would be very, very sad if that was the case. But we may never know. We may never know. So I don't know. What does anybody else think?
Obviously, we'd all like to see some sort of indication before we all shuffle off this mortal coil. But you know, it could happen tomorrow. It could happen in 100 years.
I mean, you've got the conversations about the Fermi paradox and what's the other one? The Great Barrier or something? I can't remember what it's called now. But there's two sort of
that's from Star Trek.
But that's the thing, you know. It's
great science.
I mean, the Fermi paradox is if there's life out there, where are they? And this has inspired Frank Drake, that people have mentioned in the chat, to come up with his equation, and he did it with sort of almost overnight. Produced his equation, and that's a story in itself which can be told.
Here's the thing.
Sorry, Carol.
What? So what? I mean, microbial life. Okay, it's interesting. That will be a huge finding if we find it in our solar system. Outside our solar system, we're not going to find it anytime soon. And as you're mentioning, Daz, the distances between stars are so vast, between galaxies even more vast. The ability to communicate with other civilizations is, with the physics and technology that we think we can understand, essentially zero. Whether they're out there or not, we are effectively alone. Who designed this universe? This sucks.
Yeah. Obviously they didn't want us talking to each other. Didn't want us talking to each other. I mean, going back to SETI and the Arecibo message, which was a bit more of a gimmick rather than actually a serious attempt to contact ET. That is gone to M13. What's that? The Great Cluster in Hercules.
Yeah.
And it's basically it's a round trip for the signal to get there, 25,000 years, and then it's got, if anyone does reply, it's 25,000 years back. But of course, Arecibo isn't there, so they're just going to get a dead tone. There won't be a ringing tone. So yeah, and that's what I mean. It's to send. I mean, radio signal is not the way to go unless you've got super duper transmitters and receivers that can actually detect these things, and it's got to be in line of sight, basically, which is another problem.
Yeah, absolutely. And Ian mentions, of course, panspermia. This idea that life moves from system to system, hitching a ride on asteroids or meteors or whatever. So there's that to consider. So anyway, I'd like to move on to another question now. But basically, I think the consensus that we've reached, Paul, is that we're pretty convinced there's life of some sort out there somewhere, but finding it may take some time. Yeah. Is that a fair
Yeah. So we're sitting on the fence.
Yeah. Right. Another question from somebody called Lou. Lou actually wants to know which came first, the galaxy or the black hole.
I think that's your question, Andy. You're the high energy guy.
Well, I mean,
I don't know the answer.
He's put you on the spot.
Yet again, the jury is really still out. The latest results from the Webb that has found these supermassive black holes just a few 100 million years after the Big Bang, it seems to be telling us that probably the supermassive black holes came first, and the model for this is that they would have spontaneously collapsed from dense clouds of molecular hydrogen spontaneously collapsing under their own weight into a supermassive black hole, and then the galaxy formed around it. But there are a few problems with that. I'm going to say I think we need to wait for more Webb data to give a definitive answer.
If I can just chip in, I mean, we know that, or we hypothesize, and I think we've actually seen them in some of the Webb data, that the first stars were huge.
Yeah.
Because that they had literally unlimited amounts of hydrogen and helium, and as they collapsed, they were huge. They only lasted a few thousand years, and then they would collapse. But they were so huge that they probably did collapse straight into black holes. So, but then again, what you then you've got to talk about is that because you've got a black hole. And with the angular momentum of it, did that draw the stars towards it, or did it create, of course, with all the eddies that would create, is that where the stars created? Or did the stars coalesce towards each other? And then a load of them collapsed into each other, causing the black hole. It's just, like I said, it's a chicken and egg scenario, isn't it? We just don't know.
No, and these supermassive black holes, we didn't expect to find them so early in the history of the universe. So how exactly they got so massive so early on in the universe's history is a question that obviously everybody's asking at the moment. I think, bear in mind that the lifetime of the James Webb Telescope may be 20 years, and we're only 2 years in. So we've got a lot more data to come yet, and I think the question will be definitively answered by the time the Webb Telescope comes to an end. So watch this space, basically. I think,
and not only the James Webb technology, but as it's discovering new things that we don't understand, like well-formed galaxies near the beginning of time, we have a chance. We have 20 years to reform our theories about the universe to try to match the observations, and then we'll have more observations and more theories, and that's how it works. You pair them.
Just to answer this question from AC, it says our receiver has gone, but China has fast. It's the wrong area code. So when they call that number, it's going to be just a dead tone.
Well, talking of radio telescopes, don't forget, AC, that the square kilometre array is coming online within the next probably 8 or 9 years before it's fully operational. This will be the world's biggest radio telescope, 1,000 times more sensitive than any existing radio telescope. It's currently under construction in Australia and South Africa, and as its name suggests, in total it forms a square kilometre of antennas. The facts about this radio telescope are enormous. The fact that it's 1,000 times more sensitive than any existing radio telescope is going to open up an era of astronomy like we've never seen before. Just the amount of data it's going to collect is frightening. In fact, when they started designing it, the computers that could process that much data didn't exist, and they proceeded with the design on the assumption that when they were ready to build it, the computers would exist. Luckily for them, IBM came up with the design for 2 supercomputers, both of which are 25 times faster than any existing computer today, and they need that power to process all that incredible petabytes of data that it's going to generate between the 2 sites in Australia and South Africa. And if I've got this the right way round, the mid-frequency dishes will be in Australia in the Murchison radio complex that's existing in Western Australia at the moment, and that they'll be eventually there will be 1 million mid-frequency antennas, and the low-frequency antennas will be in South Africa. So it's going to be an unbelievable era of radio astronomy. It started construction after a long period, obviously delayed by COVID last year. So hopefully by the end of this decade or shortly afterwards, we're going to see a whole new era in radio astronomy, like what we can't even imagine at the moment. Okay, now I'd like to move on to another question. Another question Lou had actually was why, since Viking, NASA hasn't sent any space probes directly to detect life on the surface of Mars. Can I just try and answer that one, so let's see what the panel think of my idea?
Did you say Voyager, Andy?
Viking probes.
Vikings, yeah. That's sorry. Yeah, I thought you said Voyager.
The results of the Viking probes were sort of inconclusive. There seemed to be something chemically going on, but it was never really established whether it was life or not. I don't think you can just put a space probe down on any location on Mars and hope to find life. The mantra for NASA since the 90s has been follow the water, because we are assuming that life will require water. So what you need to do is to trace the history of water on Mars and find out whether water is or has been, and that's the best place to search for life. And until places like Jezero Crater, Gale Crater were identified as being possibly water-bearing in the past, that's the sort of place we should be looking. And I think that's what I think is the answer, that we needed to find places where there would be life rather than just setting down and hope to find life wherever the spacecraft landed. What do you think of that?
Well, one of the Voyager, you've done it myself now, Viking project scientists on the life science experiments is convinced that they actually did show evidence for life.
That's the PI for the labeled release experiment.
Yeah.
I've forgotten his name now, but yeah. Yes, because it's his experiment.
Well, yes.
Is it? And also we got the was it the Black Hills meteorite, something like that was called? The something Hills meteorite, where they
Allen Hills.
Sorry?
Allen Hills.
Allen Hills was that?
Allen Hills from Antarctica.
Yeah. I mean, it's that was. I mean, it's all like some people still say, "Oh, I don't know." Then they said it was probably something, an artifact that was created by the preparation of the meteorite and things like that. But when you look at it, it does look suspiciously like it could be a fossil. It would be fantastic if it could be proven, but it's just one of those things. Yeah. And as regards, I couldn't answer the question. You'd have to ask NASA why they haven't sent a direct.
It is a curiosity. The gas chromatograph and the labeled release experiments on Viking had some inconsistent results, and some of those inconsistent results were positive. I'm going to show one of those in my presentation today. But Levine was the PI I was thinking of for the labeled release experiment. But they've had some time to reevaluate the construction, the design of those experiments, which I think were very clever. And I think you set it down in the right place. I agree, Andy. You don't just plop it down. Set it down in a dried riverbed or something, and drill a little bit below the surface, so you're getting past the region where cosmic rays can penetrate. And I think it's quite doable to either detect or say definitively no. The problem with detecting life, I think, is that the answer is so fantastic, so amazing, so game-changing, that hardly anyone is willing to stick their neck out for this unless the proof is overwhelming. So we need overwhelming proof.
Yeah.
Well, didn't with the Allen Hills meteorite a president stick his neck out?
Yes.
At least that. Yes.
Which I think he regrets now.
Yeah. And
hi, Rachel. Nice of you to join us. How are you? Hope you and the family are well. Right. Okay. So what we're going to do is thank you, panel, for your thoughts, and don't forget, as I said, if you would like to ask us any questions we can answer on a Tuesday, pop them in the Your Questions Please chat on the Facebook page, which you'll find by going to Facebook. Just search for Space Oddities Live and you'll find us. And just pop them in the chat and we'll do our very best to answer them. Now, what I think we'll do, we'll go to the news, and then when we come back, we're going to carry on this theme of life on Mars, and Lou's going to delve into it for us a bit. So let's let me just let's go to the news and what's been going on this week. Let me just set myself up here. 1 second. Just play some elevator music while you're waiting for this. Right, okay. Yeah, don't give up your day job. Okay. Funnily enough, the first item on the news tonight is about Mars. And the Mars Insight lander, which you will remember spent 4 years on the surface of life, trying to study the interior of Mars, about which we don't know or didn't know an awful lot, with the seismograph and other instruments. And what it seems to have discovered is actual liquid water. And this is in a layer starting about 11 kilometers down under the surface of Mars and may go down as far as 20 kilometers. It's assumed to be global, but this is a major step forward for the detection of water on Mars. We know that Mars has got a lot of ice, water locked up in ice. Big ice deposits found on Mars. But this is actual liquid. This is actual real water. So this is a phenomenal discovery. Now, obviously, because it's 10 or 11 kilometers down, then we can't really drill down and sample it, as it were. But it's interesting to know that it's there, and it sort of answers one of the questions that people have always had about where did all the water on Mars actually go. So this was one of the answers, that it went underground when the planet froze. So that's that. Interesting news about the asteroid that killed the dinosaurs, or at least assisted the dinosaurs to die out. Scientists have managed to work out where it came from. And this asteroid, which was 6 miles across, it's estimated, came from beyond Jupiter. And the reason that they think this is because there's a layer of an element called ruthenium at the KPEG boundary, which is the point in the strata where this event happened, this catastrophe. And ruthenium is actually very rare on the Earth, but it's plentiful in carbonaceous or C-type asteroids. So the thought is that that's what this massive rock that hit the Earth 65 million years ago, that's what it was. It was a carbonaceous asteroid. And these asteroids form out beyond the orbit of Jupiter. So the likelihood is, if the data is correct, that massive space rock came from beyond Jupiter, and it was probably flung into the inner solar system as the result of collision with another object. And it just happened that the Earth was in its sights, and we know the rest. So this is a big step forward. On the left, you'll see a picture of an asteroid called Matilda, which is a carbonaceous asteroid, and this is sort of what they look like. Lou, have you got any comments about that? Lou or Aaron, any comments about this?
Aaron, you go first. I've got a few thoughts.
All right, so I was going to let you go first, but okay, I'll jump in here. This is the first I've actually heard about ruthenium. I know that we had a higher level of iridium in that layer in the KT boundary.
Sure.
And that was what led to the idea that it's an asteroid. But the nice idea here is now you've got a likelihood that you can pinpoint it out beyond Jupiter as one of the carbonaceous asteroids. So I think that's a wonderful thing.
Isn't it?
Yes.
Yep. Lou?
To you, Lou.
There have been some thoughts about whether it was an asteroid or comet. We tend to put these two items, these what we call in the business, we call them small bodies. We put them into two separate buckets, right? They formed far out in the outer solar system. They're probably comets because water could condense, and they've got a lot of higher water content, and if they formed it closer in, probably asteroids. But I think in reality, it's probably more of a continuum, right? So this was ruthenium. So I haven't heard of this before too. And iridium is what I've been kind of schooled on. I don't know if that's plentiful in comets. I don't know if that's ever been discovered in comets. Of course, we're talking about the surface of comets, not the bulk composition. So when we say all this, they're not doing orbital mechanics. They're speculating on where it came from based on this element. And I wonder if this element could exist also in comets, or if it's ever been discovered in comets.
Yeah, good question. If it turns out, of course, that it's never been detected in comets, doesn't mean it doesn't exist, of course, but if it's actually never been detected, then that would come down fairly heavily on the side of an asteroid, wouldn't it?
Mm-hmm. Think so.
Yeah. Interesting. Any of the other guys? Anybody else got any thoughts on that?
No, I think everything's been said. It's another clue, isn't it? It's another clue, and the more clues you get, the more you can actually start then to form a hypothesis. So, yeah, it's very, very interesting. Very good. Very good.
Indeed.
It does I got to jump in here. It does beg another question in my mind, which is, we've known about this KT boundary layer for a while.
Mm-hmm.
We've known that it had iridium for a while. When they did the analysis on what the materials were in that layer, how come they didn't notice the ruthenium earlier?
Good question. Good question.
Mm-hmm. A plot, you're suggesting, perhaps.
Oh, just curious.
It could be that you need a specific technology to detect ruthenium.
They'd be able to do that on a mass spec machine, detect ruthenium very easily.
Yeah. I'm just reading actually about ruthenium. Just give me 1 second. I'll tell you a little more about it. Because I'd never heard of it till I came across this. It's not an element I'm familiar with. So ruthenium, what have we got? It's a rare and resilient metal. It belongs to the platinum group of metals. Mm-hmm. It's characterized by its rarity, hardness, and resistance to corrosion. Silvery white, lustrous metal, extremely hard, brittle, and resistant to corrosion. One of the rarest elements on the Earth, found in platinum ores and as a byproduct of nickel refining. So perhaps it was overlooked because of these reasons. It was the last of the platinum group metals to be discovered. And ruthenium tetroxide, RuO4, is highly toxic and volatile. So there we are. So interesting.
Because just as on this subject, AC, it says, if the asteroid had hit elsewhere without some more sulfur, the dinosaurs would probably never have died out, because the Chicxulub impact occurred in a region with rocks composed of the mineral anhydrite, which is a calcium sulfate mineral. Sulfur vapor was also injected into the atmosphere, into the stratosphere. Sorry, I'm not sure about that. I didn't know what.
That's an interesting thought. So if it had hit somewhere else, it wouldn't have caused the devastation that it did. It wouldn't have affected the atmosphere so much.
I think also, I mean, you would have had literally like an atomic winter anyway.
Yeah.
Which would have
all the smoke.
Yeah, and like I say, there would have been other poisonous vapors, no doubt.
But thank you, AC. That's interesting.
That's an interesting comment. Yeah, thank you for that.
Moving on. We're staying with asteroids, believe it or not. We're staying with everybody's favourite asteroid at the moment, Psyche. Psyche is an asteroid that has garnered a lot of attention, and a space mission, because it is it's a main belt asteroid. It's 173 miles across at its widest point because it's sort of potato-shaped. We did think it was completely made of metal at one point, and therefore perhaps it was the core of an ancient planetesimal. But more recent studies have shown it's probably more a mix of metals and silicates, because when people were saying that it was totally metal, its net value with all these precious metals was put at $16 quadrillion. Not that means anything, of course, because it's going to cost more to get the metals than you could make in terms of profit. But the interesting thing is, in 2017, they looked at the spectra of Psyche and discovered traces of hydroxyl or OH molecules, which are part of water. But it was inconclusive that it was actually there. But now the James Webb Telescope has had a look at the infrared signature of Psyche, and it's confirmed the existence of those hydroxyls. And the spectrum is very similar to certain rust-bearing carbon meteorites. So what they think is that the surface of Psyche, at least at the poles where they got the strongest infrared signature from, is coated with a layer of rust. So Psyche is actually rusting because the hydroxyls are bonded with the metals. So that's quite interesting. Now, of course, don't forget that apart from anything else, they wouldn't have been born there on Psyche. Probably they would have been delivered, those hydroxyls, from collisions with water-bearing asteroids. But the presence of water itself is not completely being ruled out on Psyche. So we'll have to wait till the NASA Psyche spacecraft, named after the asteroid, it's on its way, and it arrives at the asteroid in 2029. So we're going to get a close-up look at this most bizarre object in the solar system. Anybody got anything to say about
that? Yeah, like you said, when the actual probe gets there, the Psyche probe, it's going to be an absolutely fascinating mission, because just the actual mission itself and how it's going to start orbiting, it's going to map the whole thing. It's going to use a magnetometer to gauge where the thick metallic items are on the surface or embedded, because it's only then once it's analyzed all this, it can actually arrange its orbit, because you don't want sort of like some of the extra gravity pulling in certain places, also extra magnetism pulling it in different directions. But the whole thing, because again, as you said, originally it was thought to be the core of a protoplanet. And this is why they were speculating that there's going to be lots of gold, silver, all the heavy metals under the sun in there. But until we actually get there, it's all speculation, because some of the surveys that have been done from Earth also thought that it's honeycombed.
Yeah.
So right. Until we get there, we don't know. But it's going to be
roll on 2029, basically.
Yeah.
So we will find out. Okay.
I think it's exciting that it's only 5 years away. That's not too bad.
No, that's not too bad at all. It's and as you know, Aaron, once we get to our age, time moves a lot faster anyway. So it'll be in the blink of an eye.
Yeah, just don't unplug me yet.
Okay. Last night saw something really special from JUICE, who we mentioned earlier. Very special maneuver was carried out last night around midnight, and it was an Earth flyby by JUICE. Now, JUICE is the Jupiter Icy Moon Explorer, from the European Space Agency, which is going to spend 3 or 4 years orbiting 3 of the moons of Jupiter, or flying by 3 of the moons of Jupiter to study them up close, those being Ganymede, Callisto, and Europa. It's not going to bother with Io, because it won't be in the right trajectory for that. But last night, in an effort to accelerate itself towards Jupiter, it performed an historic first. And it was the first ever Moon-Earth flyby. So it flew by the moon, which deflected it towards the Earth, and then flew by the Earth, which was a first, because it was the first ever double gravity assist on 2 bodies in quick succession. And the Earth's gravity put it on the right course for a Venus gravity assist. It's going to fly by Venus next year. So I thought we'd have a look at the trajectory. You can see what happened here. It flew by the moon, and by the Earth, which altered its trajectory and accelerated it with the so-called slingshot maneuver out towards Venus. And it approached the Earth to within 6,807 kilometers. It could actually be seen in the night sky across the Pacific and parts of Asia. And I haven't seen any reports that anybody did actually see it, but technically it was visible in the night sky as it zoomed past the Earth at sunset.
Just one Earth radius. That's
exactly.
really close.
Yeah, really close. So I've been looking for reports today that somebody actually saw it, but I haven't found anything because it was traveling. I can't remember the speed, but it was traveling at a hell of a lick. So that's what happened. So I thought we'd just have a look at the JUICE mission milestones so that you know what's happening. So it was launched on April the 14th last year from the ESA spaceport in Kourou, French Guiana. As we said last night, it had the first gravity assist, the double gravity assist from the Moon and the Earth. It's got a second gravity assist at Venus in 2025, a third gravity assist at the Earth in September 2026, a fourth gravity assist at the Earth in 2029, the last one, which will then fling it out towards Jupiter, all of those flybys and gravity assists having accelerated it dramatically, so that in fact it only takes 2 years after that to get to Jupiter, where it arrives in July 2031. And from 2031 to 2034, it's going to perform 35 flybys of Callisto, Europa, and Ganymede. And its resting place, if you like, will be when it's inserted into orbit around Ganymede in December 2034. So there you are. So this is what we've got to look forward to from JUICE. So I mean, I've been, like the Europa Clipper, which the US is launching. We're going to have 2 spacecraft exploring Jupiter space, exploring the moons, which is going to be absolutely glorious.
Yeah. Because wasn't it JUICE that also gave us those stunning images of the what was I going to say, the asteroid, and then we sort of found it had a little baby, and then that turned out to be twins.
Was that JUICE?
Was that JUICE?
I can't remember.
No, I don't think it was JUICE.
Oh, okay, then I'm talking about the wrong one. Right,
no.
Ignore that then.
The only thing I've seen from JUICE is a lovely look back at the Earth as it was leaving Earth orbit.
Oh no, that was.
No, I can't remember.
What was the fossil? What was the fossil called? Yeah.
Anyway,
Australopithecus fossil that they found in Africa.
Lucy.
Yes.
Lucy. Yeah. Sorry.
That's right.
Sorry.
Yeah.
We digress.
So that's the program for JUICE that we've got coming up, and of course we will, as ever, keep you informed of anything that happens. We've got a great launch next week, guys. Polaris Dawn launches on Monday. This groundbreaking mission on a SpaceX Dragon, being captained again by Jared Isaacman. And because of the last mission that Isaacman captained, it's a private space mission, obviously, they managed to raise $250 million for St. Jude's Children's Cancer Research Hospital. And they're going to be raising money for the same hospital again. So this is amazing. But this that in itself is fantastic, of course. That you see the real benefits of spaceflight here, $250 million to a children's cancer hospital. If anybody moans to you about how much money is spent on space, just point them on that and tell them they're an idiot. And but this is going to be groundbreaking for lots of reasons. Let's have a look why. It's on a 5-day mission. It will achieve the highest Earth orbit ever flown by a spacecraft, reaching approximately 1,400 kilometers above the Earth. It will conduct the first ever commercial spacewalk using spacesuits designed by SpaceX. It will test communication with Starlink satellites to provide incredibly valuable data for future space communications systems using lasers. And it will conduct scientific research to advance human health on Earth and understand human health during long-duration space flights. It's a fascinating mission. Let's just have a look at the medical experiments. A nasty condition called venous gas emboly will be investigated using ultrasound to monitor, detect, and quantify it, which will contribute to studies on human prevalence to decompression sickness. Gather data on the radiation environment to better understand how space radiation affects human biological systems. Provide biological samples for multi-omics analysis for a long-term biobank which is what they want to set up to take samples from asteroids who've flown in space, to have a bank of samples for research purposes. And also spaceflight-associated neuroocular syndrome. And this is a condition that astronauts suffer from, but basically their eyeballs change shape in space because of the microgravity, which leads to a lot of problems after space missions with astronauts' vision. So they're going to be doing a lot of research into that to work out how to combat that. So I'm just glad that's not something that happens to me, obviously. So this is an important mission, and it launches next Monday at 8:38 in the morning, UK. We will be covering it live on Space Oddities here, and our live coverage will start at 8:15 a.m. UK next Monday morning. And we hope you can join us to watch the launch. And we will, of course, try and bring you coverage of the whole mission as we go forward. It's an incredibly exciting mission. Can't wait to see what the spacewalk looks like. I can't wait to see the images. But it's a really innovative mission. And as I said, it's going to raise probably lots of money, again, for children's cancer research. So fantastic. So who's up for joining me on Monday morning then, guys?
Yeah, I'll be there.
Yep.
I'll be there.
Bank holiday, so I won't be at work.
Oh, great.
Yeah,
Fantastic.
yeah.
So
Yeah.
we'll bring you
And
live coverage.
of course, look through our library of past shows, because we had Mr. Petit,
Yes.
one of the astronauts who will be flying on this mission. We had a chat with him several months ago.
Yes, we did.
So go back and have a look and refresh your memories of what will actually be going on.
Yeah,
Yeah.
absolutely. Absolutely. So we're really excited about this mission, and we wish them the very best of luck, and we hope you can join us for the live coverage of the launch on Monday. Our coverage will start at 8:15 a.m. Again, it won't be previewed on the channel beforehand because of this bug that we have at the moment. So just as you did this evening, just go to the channel. It will suddenly pop up as a live stream. So that's that. Okay, lastly today, bad news, conversely, about space exploration. There was a bit of an accident at Britain's first licensed spaceport on Saxavord in Shetland, on Uist, the island of Uist, yesterday. The German company RFA, Rocket Factory Augsburg, were doing a static fire test of their rocket. They were hoping to launch for the first time with the first flight out of the new British spaceport in a few weeks. And they did a static fire test a few weeks ago with 4 out of the 9 engines, and that went fine. Yesterday, they mounted all 9 engines on the rocket, and look what happened. There was an explosion. One of the engines blew up, followed by a fire. And it is Britain's first licensed vertical rocket launch facility. Nobody was hurt because obviously the area around was evacuated, as you would expect in a static fire test. And lots of incredibly black smoke there. And they obviously are examining the cause of this anomaly. But there was one word in the official press release from RFA which would explain everything, really. And that word was iterative. They are following SpaceX's example of doing iterative testing, where basically you build something, you test it. If it goes wrong, you work out why, fix it, and build again. This has allowed SpaceX to develop rockets at an incredible pace. Oh, that's pretty nasty, isn't it? And RFA following the same example. So they will do what SpaceX did. They will work out why it went wrong and fix it, and then build again and test and build again and test until they get it totally working. So there we are. So bad luck, RFA. But, both RFA and Saxavord have been at pains to point out today that it is a setback, but space is hard. This is a brand new rocket. They were sort of expecting it at some point. So it will delay the launch, obviously, but there's no greater damage than that. Apparently, the launch pad, although it didn't look like it in that video, the launch pad survived largely unscathed, although, as you saw in the video, the rocket itself was completely destroyed. So there we are. So that's the news for this evening, guys. So thank you for your comments. And let's move on. So
There's just a question just popped in from Graham.
Mhm.
Says that highest Earth orbit number. Surely Apollo was higher Earth orbits until it was captured by the moon's gravity. No,
No, don't think it was.
No.
because it had to travel to the moon. It wasn't actually orbiting. It only orbited the moon once it got there. But yeah, this is up in. Somebody did mention. I see they will be in the highest orbit, and it will put them in the Van Halen belt. So again, they're going to be monitoring the well-being of the crew at all times, and I should think there's probably some sort of abort procedure just in case.
So because Apollo was transiting to the moon, it technically wasn't in orbit around the Earth.
Yeah, AC here says yes, but Apollo is traveling at 25,200 miles per hour. That is escape velocity. So that's not orbital velocity.
No, that's right. That's not.
Yeah, of course. Yeah.
I'm just checking this. Just 1 second. Of course, we always like to check these things. Let's have a look. Yeah, it was only 183 to 187 kilometers above the Earth, Apollo 11, before it was injected into lunar transit.
Right. Yeah.
So a lot lower than the Dragon will be. Okay, so carrying on with what we've been talking about this evening, we now bring you Mr. Lou Mayo, and we've talked about life on Mars this evening already. But Lou, there has been this discovery of this rock recently that appears to have some sort of evidence of ancient microbial life, and let's get Lou to tell us exactly what's been going on here.
Yeah, well, there are a lot of rocks on Mars, so let's start with that. So look, every now and then we, the members of planet Earth, hear about a new finding about and the headline will be written "Evidence of Life?" ? Right? And I think we need to be careful how we report these things, because as we were just talking about, the metric, the criteria of proof for something as extraordinary as finding life outside the Earth is pretty high. So the answer is that no one in the scientific community, well, except for perhaps Levine, I think, is willing to stick their life out and say that we've discovered life anywhere except for Earth. But there have been interesting discoveries over time. And as we look at Mars, especially, Mars it's the most fickle planet you can imagine. It was a god, then it was alive, then it was dead, then it was alive, then it might have, then it was dead because of cosmic radiation. Now it's alive again. We don't know. But I'm going to take you a little bit through the history of Mars exploration very quickly. There are only 18 slides here, but you get a kind of wet your whistle. You'll get an idea of what's been happening with that. And we'll talk about this new rock, yet one more rock that is seductively consistent with the possibility of life. So let's get with it. Okay, there's Mars, right? That's the Mars we all know. This is a Hubble image, by the way. It has polar caps, a lot like Earth. It has an atmosphere. Earth has an atmosphere. It has winds. It's pretty dusty. And we see Mars here like this, and this is the Mars that we all know. However, right, all of you astro fans will be familiar with this drawing. This was made by Percival Lowell in 1897. According to Lowell, who was observing Mars through the Lowell Observatory refractor, there were canals on Mars. The dark patches that you see here in the southern hemisphere which is in the upper part of the map, were probably seasonal swamps, he believed. And he's a legitimate scientist, okay? And the straight lines appeared to be artificial waterways that conveyed, water down from the polar caps to irrigate crops. And so the dark circles below that, he speculated were crops, right? So this is all speculation, but in his mind, these things could not occur naturally, right? And now, this is not what Mars looks like. not in the images that we take as amateur astronomers, not in the images that Hubble takes or larger observatories on Earth. So it's not exactly clear what he saw, but some have speculated that the lens in the eyepiece he was looking through was reflecting the back of his eye that had veins in it. So perhaps you're seeing a map of the back of his eye. Looks like he needs to see an ophthalmologist as I look at this, perhaps. But we don't know. In either event, this was the kind of accepted knowledge of Mars during the late 1800s. Okay? So Mars is alive with perhaps intelligent life. Then we sent the first flyby mission to Mars. This is Mariner 4. And it had a camera, had a TV camera on it, a big, fat, heavy TV camera that took very low resolution images and stored them on a 4-track tape recorder on the spacecraft. It took 22 pictures, and along with other instruments that looked for evidence of magnetic field and fields and particles and that kind of thing. And from the data that we got back from Mars here, back in 1965, Mars is dead. There are no canals. There are certainly no intelligent life. It doesn't look like there's any life at all. It looks more like the surface of the moon than anything that might harbor life, just completely pelted with craters. A very thin atmosphere, no magnetic field. Mars looked like very much, and cold. Mars looked very much like a dead planet back in the 60s. Then in the 1970s, we launched two Viking spacecraft, which were actually two spacecraft in one. Each one was a combination of orbiter and lander. The image on the bottom here that you see is an image taken by the Viking 1 lander just shortly after it touched down on the surface of Mars at Utopia Planitia. And this is at about 47, I think, degrees north. And it touched down in 1976. I remember being at Goddard Space Flight Center in their big auditorium for these first Viking images. And they came down so slowly. There'd be one thin line that went across the screen, seemed like it would take forever. And then the next thin line, and so on. So it felt like it took forever. It was probably about 5 minutes to produce the whole image. But that's the first image of the surface of Mars from the lander. The top image is the first panorama of Mars taken from the Viking 1 lander. And their objectives were to, these two spacecraft, to obtain high resolution images of the surface of Mars, try to characterize the structure and composition of the atmosphere, as well as the surface, and then also in orbit to get a sense of the fields and particles environment around Mars. So Mars is looking at least interesting at this point in the 1970s. Okay. The Viking landers, the two identical landers, had another science objective, and that was to look for the presence of life. So different than what we've been talking about. Not the conditions of habitability, not past life, not organic compounds that might lead to life, but to look for the presence of life. And this in this case, microbial life. And there were a few experiments on board, label release experiment, the gas chromatograph experiment, which essentially did this. There was an arm on the Voyager. It scooped up dirt. It put it in a canister, closed the canister. In this case, it added some radioactive elements to the canister. If there's microbial life that is exchanging with the atmosphere in the canister, then it's going to breathe in the radioactivity. And then at some point, as you're noticing here in this graph, it added nutrients to that canister. Now the red graph up here is the actual data of adding those nutrients, and you see a jump up here of the amount of radioactivity that is detected in the canister. One conclusion you could draw from this is that there are microbes in the soil. They are breathing in more radioactivity. When you add the injection of nutrients, they become healthier and they thrive better, and you're going to detect more radioactivity in the air inside the canister. The blue line down here is the control data. So I believe this is what happened after that. So there's the red is the first measurement, and then they heated the canister up very hot to kill presumably anything that was in there, and try it again. And then if you don't see any activity the second time around, then you say, aha, we killed it. There was life there. And if you see the same amount, you say, well, there was no life. It's like simply a chemical reaction. This is one of the pieces of data that they received from the label release experiment. Perhaps that you're going to hear that word a lot as we talk about life on Mars, perhaps. It seems quite evident from other rovers that have sampled the surface that Mars had a wet history. There's evidence, and I'll show you some of this evidence in a minute, all kinds of evidence that liquid water used to flow in abundance on Mars, especially in the northern polar, lower altitude regions. And so here's a possible picture of what Mars might have looked like, say 4 billion years ago. Warmer, higher pressure at the surface, liquid water on the surface, an active magnetic field that is deflecting the solar wind, liquid water clouds. This is quite a possible scenario. And with the discovery of water or the former presence of water on the surface, all of a sudden Mars is quite alive again, and a real possibility for a place that you might find some sort of life. We have flown assets in orbit around Mars. We've detected with subsurface radar, we've detected the presence of water or water ice, inconclusive, but essentially reservoirs under the surface, as well as chloride detections, perhaps saline water. So this is all very interesting, very suggestive of the habitability potential for life on Mars at one point. Also, just out here, if you can see my cursor in the upper right, this is the Tharsis region with Mars volcano is Olympus Mons. Sorry, guys, Olympus Mons, extinct volcano. This is gypsum found in the soil. I think this is from the MERs, the Mars exploration rovers, and they discovered gypsum in the soil on Mars. Well, on Earth, gypsum forms in the presence of water. More information that Mars once had liquid water on its surface. These are measurements of surface for you guys, methane. We have detected it from ground-based observations from the IRTF on the Mauna Kea in Hawaii. We detected it with the, I believe, the Curiosity rover. And it seems to be seasonal. Isn't that something? So here in this graph, we're seeing detections of methane in the atmosphere of Mars with error bars. And you see that in the winter and spring, it kind of reaches a low ebb. And then as summer approaches, we see more methane. And then as winter approaches, again, less. This would be consistent with the presence of microbial life that is more active in the summer months when it's warmer, less active in the winter months when it's cooler, subsurface, some sort of subsurface microbial life. And consider this, methane is quite volatile under the presence of ultraviolet light. So if you're seeing any of it at all at this point in the development of the solar system, it's got to be recreated somehow. All right. So again, we can't say this is evidence for life. We can say that this would be consistent with the existence of subsurface microbial life on Mars. Just some more evidence, observations of methane on Mars from orbit this time. All right, so we mentioned the Mars meteorite, or as it's called, earlier in the show, and here's a picture of it here. And what we see is, well, it looks just on the left-hand side, the upper left, looks just like a meteorite or a rock. But if you take a microscope to it, there are these features that appear to be elongated and are somewhat consistent with, although much larger than, bacteria here on Earth. There was a big press conference for this where they said they had discovered life outside the Earth, life in this meteorite. And with further analysis, it was a little quick, right? That's why we need the peer review process. There are other explanations for this. So once again, observations that would be consistent with life, but not conclusive. Down in the lower left, you see the face on Mars. There are two pictures there. One on the left was taken from the Viking mission. Just happened to snap it. I mean, it was complete accident, so to speak, and it looks absolutely like a face. The Martians are clearly trying to communicate with us. But 20 years later, the Mars Global Surveyor spacecraft took the same picture, and it doesn't look so much like a face. It's kind of a mesa. So there are two possibilities. One, it's a mesa, and it's not some sort of communication method or some altar that the Martians have erected. And the other is that the Martians had 20 years to hide the evidence. So we don't know what it is, but it would be, it's interesting. And then, of course, the lower right, you see lots of evidence of what appear to be shorelines on Mars. Again, evidence consistent with the presence of huge amounts of liquid water on the surface at one time. Okay, so this is what got everybody so excited about this recently. And every now and then you're going to get excited about, oh, there's a discovery of possible life on Mars. Woo, let's go check it out. This is from the Perseverance rover in Jezero crater. This is a picture of a rock that's called the Shayava Falls rock. Okay, and what they're indicating here in this picture are leopard spots and olivine in the rock. And this was captured by the Watson instrument that's on the arm of the rover. And Watson stands for Wide Angle Topographic Sensor for Operations and Engineering. And I think about $500,000 and at least in our tax dollars went into somebody taking time to think about that. So the rock Shayava Falls was named kind of in honor of the Grand Canyon. It has chemical markings that could be a trace of life forms that would be consistent with what we observe here on Earth. That perhaps existed when water ran rather freely through these areas a long time ago. And this, in the Jezero crater, this is the area called the Neretva Vallis. It's a 1/4 mile wide valley carved by rushing water billions of years ago. Okay, so these spots that are identified, they're found on rocks on Earth, and it's exciting because they show evidence of chemical reactions, and these reactions release iron and sulfate here, at least here on Earth, which can provide an energy source for microbes, and this could be evidence of past microbial life just under the surface of this rock. So very interesting. The rocks are made of red sandstone, and so they're stained by oxidation, by iron oxidation, and in other words, rust. But within the rocks, within these red rocks, parts have been bleached by water, which contains organic compounds flowing across them. And then the oxidized iron undergoes some sort of chemical reaction with the organic molecules. So more evidence consistent with the possibility for life, but nothing is conclusive.
Sorry, Lou, can I just interrupt you a moment? Alan would like to know, do you have any idea of the scale of that rock, how big it is?
Yeah, I think it's a few feet, as I
right.
remember. It's a few feet long. Good question.
Yeah, thanks, Alan.
So what do we have? Well, we have a dead, no alive, no dead, no alive planet. At least the volcanoes are dead. It has a carbon dioxide atmosphere with CO2 and H2O ice caps. There's definitely subsurface water and evidence of previous surface water, riverbeds and other fluvial channels, as we call them. It has 2 moons, has dust storms. You know, nice place to visit, but you don't want to live there. The images on the right-hand side, on the lower right, are magnetometer data taken from the Mars Global Surveyor Orbiter. And basically, it's kind of, I'll just use this word loosely, dragging a magnetometer around Mars to detect magnetic fields. So Mars doesn't have a global field like the Earth does, but this is evidence that it used to. Mars used to have a magnetic field. The magnetic field went away when its dynamo froze out. And when that happened, the magnetic direction in the soil was frozen out. And we're seeing evidence of that here in this colorized data, kind of GIS'd onto the surface of Mars. So here's evidence that Mars used to have a magnetic field and it doesn't. Why is that important? Because Mars used to have, from all other pieces of information, a much warmer, denser atmosphere that allowed liquid water on the surface and perhaps supported life. What happened to the atmosphere? The dynamo froze out. Its magnetic field no longer protected the atmosphere from erosion by the solar wind. And so the water got photolyzed to hydrogen and oxygen. The hydrogen escaped quite readily because it's light. The rest of it got either absorbed by rocks or remained in the form of water seeping down below the surface, as Andy was just mentioning. In terms of the erosion of the atmosphere, we sent the MAVEN spacecraft to Mars to find out if what was the primary tool for the erosion of the atmosphere, and the results that it returned were consistent with most of the atmosphere was ejected by the solar wind erosion. But a lot of water remained, and it turns out that it's probably below the surface. This is actually not a very good graph because it's hard to see, but the point here is that the United States, ESA, Japan, India, Russia, all sent, sometimes successful, sometimes not, both orbiters and rovers, and landers and rovers to Mars. It is the only planet in the solar system inhabited entirely by robots. So there you go. So just a huge, we're spending a lot of tax dollars on this. Here's a picture of some of the rovers. Curiosity on the upper left, Insight on the upper right, Perseverance on the lower left, and in the lower right, what would have been the Mars Sample Return Mission, which would have gathered up those canisters of soil on the surface of Mars, put them in a rocket, and shot them back off to Earth. That's been enormously defunded. And so we're going to have to wait, I suspect, another decade before that happens. Oh, you're not supposed to see. This is a classified image. You're not supposed to, turn it off. Turn it off. Turn it off.
It's Marvin.
Yeah,
Marvin.
Just forget. People will be knocking on your door shortly.
Men in Black.
So that's kind of the short history of Mars exploration and the search for life. And if you have questions, we can entertain those now.
Yeah, thanks very much for that, Lou.
Very good. I enjoyed that.
Very
Yeah,
informative. Yet again, we find ourselves saying we don't know. We're going to have to wait and see.
This is the best thing about being an astronomer. You can talk forever and ever about things you don't know. and sound knowledgeable.
Absolutely.
It's just great.
So Derek says Mars must have had a weather system because there's no sign of the great bombardment washed away like here on Earth.
Likely Mars had plate tectonics at one point.
Yeah.
Not since about 3 or 4 billion years ago.
Yeah. Keith paid you a nice compliment, Lou. He says, excellent presentation. Thank you for that, Keith.
Thank you.
Glad you liked it. Ian says, thanks, very useful. So there we are. Now, any questions, panel? Any observations?
I don't think we covered it. It's just...
Yeah.
So.
Aaron, you going to say something?
Yeah, I've got one. The evidence that I've seen in your presentation, but also previously, is very inconclusive about signs of life. But I think it's very conclusive about signs of water. You mentioned the obvious effects where you get the edge of the lake where you can see different levels of stratification. But the reality is there's a lot more than that as well. There are teardrop-shaped islands and channels and just all kinds of stuff that implies flowing liquid, probably water.
Absolutely right, Aaron. Tons and tons of evidence. Morphological evidence that we're talking about, compositional evidence. It's overwhelming that the evidence that Mars once had enormous amounts of water on the surface.
Yeah. And it's a shame about the sample return mission, isn't it?
Well, in some ways, because it was going to consume a huge chunk of the planetary science budget to mount that. So, swings and roundabouts, really. It was going to be horrifically expensive to mount. But NASA are inviting, everybody, companies and agencies to come up with a cheaper alternative. So we'll see what happens.
Hey, we are just one aircraft carrier away from finding out about everything we want to know about Mars.
All right.
Just take the money from one aircraft carrier, put it into the NASA budget. It's done.
Yeah.
When you put it like that, it's frustrating, isn't it?
Yeah.
It's
and that's not going to happen, is it?
No. Or you could do both. Send an aircraft carrier to Mars. Kill two birds with one stone. There we are. Job done.
My God, you heard it here first, Andy.
Absolutely.
Well, we could join forces, British aircraft carrier and an American aircraft carrier.
That's right. That's right. Not a Russian one. That'll probably crash.
That'll make it a task force, won't it? I think they're being invaded.
Yeah, absolutely. So anyway, thank you, Lou. It's a subject I'm sure we will return to in the future because it's a fascinating one. And, you know, the latest supposed evidence for microbial life in that rock came out of nowhere. These, you know, discoveries that Perseverance and Curiosity are still making. So we don't know what the future holds. So there we are.
Yeah, but it sells magazines, so
yeah,
it sells newspapers.
It sells newspapers. Absolutely, absolutely. So there we are. Okay, just before we go on to the final section of today's program, which is, as always, Daz's Solar Watch, and I'd just like to say a few words about how you can support Space Oddities if you would like to. You can buy us a coffee, and any money that you give us via Buy Me a Coffee is put to good use. All the money we receive in donations from you viewers goes towards keeping Space Oddities going. So we're always very grateful and very appreciative because we'd like it to keep going. We want to keep delivering the universe to you every Tuesday and all the other videos. So you can scan the QR code. There's a link just come up in the chat as well. You can use the super chat icon in the chat as well to donate a sum of money directly to us. You can also have a super sticker that you pay for, which makes your message in the chat stand out like a sore thumb, if you like. So there are a number of ways you can subscribe us, but the best way to support us is just to keep watching us on Tuesdays, so that the YouTube algorithm gets to notice us more and shows our videos to more people, and therefore generates more advertising revenue for us, which enables us to do the things we want to with the channel. So anything you can spare is much appreciated. Okay, so there was something else I was going to say about that. Never mind. Oh yes, just before I forget, I mentioned earlier that we're doing the live coverage of the Polaris Dawn launch next Monday. Should point out, of course, that it's always, as always, subject to change. Launch times and dates are always subject to change. Keep your eye on the Facebook Space Oddities live group. If there are any changes to our projected time of going live with Space Oddities at 8:15 next Monday morning, UK time that is, we will announce them on the Facebook page. But as always, keep your eye on the Facebook page because that's where we will announce things. We do hope you can join us for the live coverage of what promises to be a most fascinating mission. It's been a long time coming. We did speak, as we said, to Scott Petit, the astronaut, on one of the crew here on Space Oddities a little while ago. And it's been a long time coming with lots of delays, but it looks like we're finally going to see the launch of the Polaris Dawn mission next Monday. We hope you can join us and keep an eye on the Facebook page where we will post any changes to our plans. So this evening, lastly, we come to Daz, and Daz is going to tell us what's been going on with the sun. There seems to have been a flurry of activity this week, although not really resulting in any.
No, it's well, basically, this isn't going to take long. Let's put it that way.
Okay.
Before we start, thank you, Ian, for your generosity. Every penny counts. Thank you. That's very great. I see that people are still talking about water and subsurface water on Mars and that. So yeah, keep the conversation going. We like to hear your views. So yes, thank you very much. Well, as I said, this isn't going to take too long, unfortunately. Basically, as I said, the usual start. Here's the two images of. Oh, hang about. I got to. I've forgotten. Sorry, this is my fault.
That's all right. No problem. Daz is just going to crank the turbine up.
Yeah, put the gas up. Turn the gas up. Can you see my cursor now?
Yeah.
Yeah, thank you. Right, so here we are. We start with the usual picture. This is on the left-hand side. You've got last week's sun with its active regions all labelled, and on the right you've got today's. You can see they're virtually pretty even. In fact, last week we ended the week with, if I remember right, 10 regions, but on today we've actually got 12 active regions, labelled regions actually on the sun. But I don't think there's actually 12 there, but they said there are 12 on there. again, we've got sort of like mixed magnetic complexities going on with some of them. But I think it's 3794 has been our big player towards the end of the week. But we've had, over the week, we've had 85 flares. Most of them have been C-class flares. But we have had quite a few in there, M-class flares. And although I say they're C-class flares and M-class flares, as I said, they still give us radio interference at the lower levels of frequencies on the Earth's surface. So even though we're sort of like being, we're not trying to sound dismissive, but the thing is, every flare creates a reaction on the Earth. So don't think that these, because I say they're C-class flares, that means they're not very, they don't interrupt us at all. And of course, as the flares gain in strength, that means they just rattle our magnetosphere, our protective shield, just that little bit more. But saying that, at the beginning of the week, the next day on Wednesday, we did have an X 1.1 flare, which also had associated with it a partial halo, and that was from AR 3784. So of course, now that's just disappearing off the western limb, but it was quite central, and also at the time, just above it, there was quite a big coronal hole, which was producing quite a bit of space wind towards us, solar wind, and that helped deflect with the eruption from 3784 more towards us. It pushed it down more onto the plane of the ecliptic, and so we knew something was coming. We weren't really sure at the time that it actually happened, because at the same time, an event happened just off the western limb, which produced an expulsion. So the halo, for a little while, until it was studied, was actually lost. So we were all speculating. But anyway, as I said, it gave us a partial halo, which did throw actually quite a bit of sun material, energized particles towards us. So we were sat there in anticipation, waiting to see what will actually happen. And of course, we did actually get hit on the Saturday. But I'll come to that in a little while. So there we go. That's those two. Let's just move on one. Now, here we are. This is again on the right. That's today's sun. And this is the magnetic configurations of these sunspots. And of course, these are the more letters they've got in there, the ones in the red are the ones that have got more complexity and more likely to give us some really energetic flares. And I think it's 3794 became the main player towards the end of this week. So again, it took over, and as you can see, it sat in the middle, but it has been giving us some main place. I think it gave us, let me just check, I think it gave us 3 flares today. No, sorry, it's 3796, wherever that is. Oh, that's over on the far side. That gave us 3 flares today, but M3794 has been active during the week. So that's the configuration. So we'll be looking at these now. With this all active region here on the eastern limb, there's a lot more to come from around this side, and you'll see on when I run the videos in a second that there is a lot more that's coming around the corner. So I'll just like so you can see that we have got some that have got magnetic complexities, which will give us some bigger flares. There also are some coronal holes, but they're now moving off towards the western side of the limb there now. So here's our usual view. It started off with, it's just gone past the X1.1 flare. You can see there's action going on the western side. You can see this now coming in around on the eastern side, all the way across though. But all these flares are small flares that have been going off all through the week. And here comes there's some big stuff going off over in the sort of like 2 o'clock region, but you can also see these coronal holes that were also giving us some extra wind from the actual sun. So yeah, as you can see, look at this big area here that's just come round on the eastern limb, and there's still more to come from there, and these are quite big. But one thing you will notice is that when they come round, they sort of seem to start sort of like in the higher latitudes, but by the time they come round onto the eastern side, they've moved towards the equator, and as I'll tell you a bit more about that a bit later on. So that was just the normal 304 image that we normally see. Here's the magnetic image. Again, we're looking at the magnetic field lines between between the active regions and between the sunspots within these regions. And you can see again on the left-hand side, the eastern side, there are some big loops really coming around. You can actually see some of the flares and the loops breaking off. And again, on the western side, you can see them disappearing. If you think about it, if we could see it from the east or the west, we would have these loops also facing towards Earth. But we can't see them because we're basically looking down. It's only when they move around. There was a big disconnection and reconnection just sort of like a third of the way across from the left there. If you want to have a look at these, just go back later on and rerun these using on YouTube. Now, the one that gives us gives us a good idea of what's actually going on, and that's the coronagraph. So we start off with one off to the 4 o'clock. Now that's the one region. Now that big one that came off at 3 o'clock, that was the X1.1, and as you can see, it was already interrupted by the one that was going off at 2 o'clock. So the actual halo was hidden. I did have an image of the halo, a little video, but somehow I've misplaced it and I can't find it. There was something going off from the far side there, going up to the north. So as you can see, there is action going on. It's picking up again, but most of this is on the far side. So yeah, it's just let's let it finish off, and it finishes off with a big ejection down towards the 7 o'clock region. So so there is stuff going on. I've lost my cursor. There it is. Now this is the there goes the flare. That was the 1.1 X flare. I'll see if I can just run it again for you because it's a bit quick. It's the second flare. You'll see. You don't get distracted by the flare on the western limb. Just watch the bright spot in towards the middle, and you'll see it actually flares twice. And now it's disappeared. There we go. There we go. So there goes one flare. There's the second flare. That second flare was the 1.1, and that's what gave us all our excitement at the weekend. So I'll just show you now what. So this is what happened in the UK. As you can see, this was last weekend. So we've had 2 weekends of activity. Nothing like as big as what we had last weekend. But this is from I did this one on the 18th. It was just so that I could just show you the 2 weekends together. But then what we came along, and then on Saturday, boom, we started to get a pickup. Now I didn't issue an alert until literally the end of Friday night. I wasn't convinced that it was going to be big, but I thought, well, if I don't make an alert, just give you a warning, then we might miss if something does happen. And I'm glad I did, because as you can see on the Friday, unfortunately it started again during the afternoon, so it was daylight, but it did persist until about 12 o'clock. I unfortunately was unable to get anything because I was clouded out. And unfortunately, I also didn't see very many photographs of the last weekend because I think mostly it would have been, as you can see, by the time it was getting dark, we were down to amber, which is a G1. So that would have meant basically most of it is up around the Arctic Circle, maybe the Shetland Islands, or maybe even North Scotland, but that's as far as it possibly would have got. But we did get some action again. So yeah, it was a bit disappointing, but that's the way things go, unfortunately. I've got something and everything, so if we carry on. Now, this is what I said. We've actually, these are the three coronal holes that I was talking about. Number 58 was the one that sat above the X1.1 flare and helped give it a boost to give us our auroras. And then, but we're not expecting anything during the week. This is a mess, absolute mess. I will see if it would run it. No, it won't. Well, I only took an image, sorry. I thought I'm not going to run it. This is all up and down, all over the place. It's an absolute mess. But this is actually from Solar Wind. If you run this, if you go on to NOAA or anything like sites like that, or in the UK, if you go to the Met Office Space Weather and go to energy, space weather energy, you'll get these animations. But you'll see that this is actually all from wind because of the coronal holes, which are going to be passing around. So we're not really going to be expecting, maybe, no, I don't know. Even the wind towards the end of the week at the moment doesn't look as though it's going to give us anything special to write about as an aurora. But remember, it can change at any time. All you need is
love.
Well, yeah, all you need is love. But yeah, so that's basically what we're not expecting anything at the moment. So what we'll do is just move on. Now, this is what's coming around. As I said, we've still got more to come. What we've got here is this is the west limb, and this is the eastern limb. So what we've got is we've got more stuff actually traveling on to the actual facings of the sun, and it's going to give us some more, because you can see this whole black area just here is just going to be coming onto the sun's face now. We've already got this here, so we're going to get a lot more. We've got an unnumbered spot right behind it, and then you can see all this here. This is the stuff that's been left us over the last week, and it seems to be growing. Look how big these are. So these could be fun and games in a week or two. So we'll keep an eye out on that. What else we got? All right. Now, if you remember, a couple of weeks ago, I gave you this chart, and as you can see, we thought we'd possibly hit the middle of the sunspot cycle, but again, what we had August, July surprised us, and it's jumped back up again, and the sunspot count has been still quite high, so we may even go up even further. As you can see, we are now quite a bit, sort of like about 50 more sunspots, averaging 50 more sunspots than we did at the peak of number 24. But the reason I've shown you this again is that there's a story going around that scientists believe that they've actually seen the start of cycle 26. Now, you're probably saying, and I had to question myself about this, we haven't even hit officially the peak of 25. So how can they be seeing possible the beginnings of 26? Well, what it's done is they've been using helioseismology, and basically what that is that all the action that's happening, all the magnetic action, all the turmoil, all the magnetic lines and sequences, they create waves on the surface. And I'll just read you this. It says, helioseismology is the study of the interior of the sun by using observations of waves on the sun's surface. So these are sort of like things that are created by sound waves and things like that of everything that's going on. It said it's done much to improve our understanding of the interior of the sun, testing the physical inputs used to model solar interiors, and providing a detailed map of the sun's structure and internal rotation. So what they mean by that is we know the sun is a big ball of plasma, and as it rotates, it doesn't rotate uniformly like the Earth does. The actual equator rotates faster than higher latitudes. So it's actually causing a twisting action of all the magnetic fields. Now, what's happening is all these magnetic fields are giving us all these sunspots, all this interaction, and they create waves on the center, on the surface of the actual sun itself. And we can actually see these, we can actually monitor these, and they sort of like ripple. And what they're saying is that they have, during they've actually looked at, so this is a study that's lasted over 30 years. It was nearly 30 years. It was cycle 23, cycle 24, and the cycle now. And they've seen something that's happened on all three occasions. And it's that these ripples have started to move towards the equator. And of course, as they move towards the equator, they pull the sunspots towards the equator. Remember I said when we looked at those images that when you look on the right side, they seem to be at higher latitudes as well. But by the time they get to the eastern side, they seem to have moved towards the actual equator. And of course, this is one of the signs that you're coming towards the peak. And then later on, they will actually start to move away. So by looking at these ripples and studying these ripples, they have seen on all three occasions, 23, 24, and this one, that they're all doing exactly the same thing. Well, we've still got about probably 5-6 years before we actually come to the end of this cycle. But it doesn't mean that this is going to stop anytime soon. I mean, the actual peak is expected to run into mid 2025. And then we've got the decline of the actual sunspot session. And usually they can say that sunspots, usually once they decline, the actual action on the sun can actually increase quite rapidly. So we've got lots more to look forwards to. And of course, once it gets to the actual, when it declines to its absolute minimum, that's when we get the actual poles, the north and south poles on the sun will swap, and that's when we will then go into 26. But what they're saying from previous observations of these waves on the surface of the actual sun moving towards the equator, they're saying that this could be the sign that you are starting 26, because it seems to follow this pattern. But of course, we won't know until we've done a lot more observations, probably another 30 odd years, that we can say that this is a sign that 26 is beginning. So I just thought I'd like to throw that in there. Also talking about sunspots, today, I think it was today, Andy put up a show onto YouTube for us, Another Astronomical Life, and it's Maria Mitchell. She was an American lady. She was a fascinating lady, well worth a look. And she actually was a great sun observer, and so was her father. His father was a great sun observer. He was an amateur astronomer as well. She was the first professional astronomer in America, female professional astronomer in America. But she also was the first person to start photographing sunspots on a daily basis. And it was through her analysis that they actually were able to determine, she was the first to notice this, that the actual sunspots were not clouds as everybody thought at the time, but they were actually twisting vortexes going down into the surface of the sun. So she was one of the persons who actually discovered that sunspots were actually on the sun's surface, and they were actually tunnels of vortices that actually went down into the sun itself. So have a look at that, please. She was a fascinating person. So I know I'm blowing my own trumpet, but there you go. So thanks for that, everybody.
Right, thank you, Daz. Yes, do have a look at Daz's video that he's created on the life of Maria Mitchell in the ongoing series An Astronomical Life, where Daz looks at the life and work of some famous astronomers and people you might not have come across, like Maria Mitchell, who doesn't seem to be a household name in astronomy. But a fascinating video, Daz, so well done, and show Daz some love. Go and watch the video. You'll find it in the channel. There's also a playlist on our channel called An Astronomical Life, where you'll find past episodes in the series. Now, that just about brings us to the end, I think, of today's show. We'd like to thank you for joining us, especially those of you who, by the look of it, have joined us for the first time. You are very welcome. We hope you're going to tune in again next week. Don't forget, the next Monday morning at 8:15 UK time, we're going to bring you live coverage of the launch of the Polaris Dawn mission. Very important mission, very special mission. Keep your eye on the Facebook group for any changes to date and time, because, as you know, these things can get changed at a moment's notice. So keep your eye on the Facebook group. I would like to thank everybody this evening. I'd like to thank Lou for his excellent presentation on life on Mars. I'd like to thank everybody on the panel for their contributions this evening. We will be back at same time, 8 o'clock UK, next Tuesday evening. If we don't see you for the live coverage on Monday morning, we will be back on Tuesday. As I said earlier, because of problems with the software at the moment that hopefully are being fixed soon, we will not be posting the YouTube video as we normally do beforehand. So next Tuesday, just go to the channel and you should see us pop up there at 8 o'clock. So apologies for that, but circumstances beyond our control.
And thanks for the sarcasm in the chat. I see you even put YouTube to sleep by the looks of it.
Yeah. Sandra says she's going to join us on Monday for the live coverage, which is great. I know a lot of people will be getting ready for work at that time, so we might not have that many viewers. But nothing we can do about that, I'm afraid, unless you want to write to SpaceX and say, can you please change the time of the mission so we can watch it. But there we are. We're looking forward to that. It looks like a fantastic mission. And
it will be a night mission, night launch, won't it?
Yes, it will. It will be a night launch. So in America. So there we are. I'm particularly looking forward to seeing
jellyfish.
I'm particularly looking forward to seeing the SpaceX spacesuits in action for the first time. That should be really interesting.
Hey, Andy, while Daz was giving his great presentation, I did find an interview with one of the astronauts who is going to give the spacewalk, one of the spacewalks, furthest from Earth ever, floating out in space. And just a quick quote here. I think he says, let me find it here. Here it is. Help, help, dear God, get me out of here, I beg you. Something like that.
And just before we go, Aaron, could you just tell us the brief details about the solar observing channel from the Astronomical Challenge from the Astronomical League?
Yes, thank you very much. So, overcoming all of the gremlins, Andy and I were able to get the link in the chat out there. So please do go take a look at it. But the Astronomical League offers observing challenges, and we do these all the time. Right now, we have one very specific, very related to Daz's presentation, related to the solar maximum. And we encourage you all to participate. It is open to anybody. You don't have to be a member of the Astronomical League. It does have a certificate, which we will email you upon completion. The requirements are fairly simple. You do have to do some kind of an outreach activity, which could be as simple as telling your neighbors and friends that we're in solar maximum. I mean, it can be very simple. And then the only hard part, and it's not hard, is actually building a solar, a magnetometer, so you can actually measure the effects of the solar wind on the Earth's magnetic field. And it's fairly simple. All it takes is a Coke bottle, a magnet, and a mirror. And I also use one of my little red pointing lasers. And that's it. And so it's actually very simple. Wow. The requirement is to observe before the end of March and to do 50 observations and as many as 2 a day. So, not too bad. The only thing that we found about this is you have to set up the magnetometer somewhere very stable where it won't be disturbed. So I invite you all to participate. Look forward to seeing your submissions.
Yeah, indeed. Excellent. So thank you very much, Aaron, for that. So yes, take part in the Solar Observing Challenge. I've just put the link in the chat again. So go and have a look. I mean, it might be something new for you to tackle in terms of observing, something you haven't done before. And of course, it's all fascinating stuff, and it really helps science. This is the whole thing about it. It helps us to learn more about the interaction between the sun and our magnetic field, which of course is of great importance in many ways. So there you are. So that's it. Thank you so much for being with us this evening. We do appreciate you spending your time with us. Next week, I'm going to be talking about moons of the solar system. I'm going to take you on a tour of some of the more interesting things about some of the moons in the solar system. So that's what I'll be giving you next week, and hopefully you can tune in for that. And we'll have some other stuff as well, as yet undecided. So from all of us at Space Oddities, have a fantastic week. Be good, look after each other, and we will see you, if not on Monday for the Polaris Dawn launch, then certainly here again next Tuesday at 8 p.m. UK, 3 p.m. EST. So from all